Particle motion.
To find the velocity function, you first have to find the first derivative of the position function, which is given.
The position function in this case is t cubed minus 5t squared plus 4t, and the derivative of that, which equals the velocity function, is 3t squared minus 10t plus 4, which is your answer.
For part B, we need to find the time interval when the particle is moving in a positive and negative direction. In order to do this, you have to set the velocity equation from step 1 equal to 0 and solve for t.
So to solve for t, set the velocity equation equal to 0 and then use the quadratic formula to find your t, which comes out to be 5 plus or minus square root of 13 over 3.
Okay, next, plot the zeros from step 2, which is 5 plus or minus square root 13 over 3, on a number line with the set interval given.
So for this number line that we have here, we plugged in numbers between each one of the coordinates, and we found that where it says positive, the positive number, negative number, positive number, which comes out to be, if it's positive, it's moving to the right. If it's negative, it moves to the left. And if it's positive again, it moves to the right, which is explained right here. We graphed the equation to make sure our solutions were correct, and we found to be that the positive intervals in this graph are from 0 to 5 minus square root 13 over 3, and 5 plus square root 13 over 3 to 5, and the negative is 5 minus square root 13 over 3 to 5 plus square root 13 over 3.
For part C, we need to find when the particle changes direction. The particle changes direction at the zeros, when v of t equals 0.
So in this case, we found that for v of t equaling 0, the zeros come out to be 5 plus or minus square root 13 over 3, which in this case is where the particle changes direction.
In part D, we want to find the acceleration function at any time when t is greater than or equal to 0. So to find the acceleration function, you have to find the derivative of the velocity function found in the previous steps.
So the velocity function found was 3t squared minus 10t plus 4, and the derivative of that, which equals the acceleration function, is equals 6t minus 10, which is our answer.
In step D, we want to find the total distance traveled between the interval given. In order to do this, refer back to steps 2 through 4 and use your number line to set up your distance equation.
So to set up this equation, we need to use 3 different parts, 3 different intervals for our equation. So for the first part, we need to use from 0 to 5 minus square root 13 over 3, which is moving to the right, so you keep this part of the integral positive. For the next part, we need to change it to negative because we change direction and go left. For the third part, we go right, so we keep the equation positive over here.
Next, you want to integrate your 3-part integral and use FTC to find the total distance.
So this is our distance integral that we just found. And then after that, we need to integrate it, which is shown right here. And then use FTC, which is f of b minus f of a for each part of the 3-part integral equation. And our final answer is 184.552283, which is our total distance.
Woo! Calculus!
Calculus! It's not calculus, it's Kokimor.
Calculus, I love you.